All right, so let's talk more about lists. What we'll do initially is we'll talk about two fundamental functions that allow us to work with lists. One is the length function. We saw a length function with strings. It'll work here in very much the same kind of way. Then we'll look at the in function. Then we'll actually begin to write a little bit of code, which initially will involve just iteration, which should seem quite natural that we'll iterate with lists because that's how we'll actually work our way systematically through a list, which very often, of course, we have to do. So if you look at the console, I've created that same list that we had last time. It's a list named L. It contains the int1, the float 1.0, the boolean true, the boolean false, the string spam, and then it contains a sublist. And that sublist consists of the integers 2 and 3 and 5 and 7. Okay, so let's look at some functions here. First of all, the len function, short for length, of course. So we call this in the usual kind of way that we call a function. That is the function name followed by the argument in parentheses, that is length L, len L. And then notice that we get 6. Okay, hopefully you're not surprised by this. When you give the length of a sequence, like a list or a string, works in the same way in both cases, you count in, as it were, the normal way. So you start at the 1, go to the 1.0, the true, and you count 1, 2, 3, 4, 5, 6, and that 6 then carries us through the end of the list. Notice this then, that the length of the list is not the final index. Okay, since indices always begin with 0, the length of the list is always the final index plus 1, or equivalently, the final index is the length minus 1. So here's something that we might try to do. This is a way that people often get index out of range errors. We might try to extract the final element in a list in some such way as this. So we have the list name L followed by the square bracket operator, that is the index operator, which we use to extract elements. And then, well, what I've got here is simply the length of L, which is 6. So that asks for the element at index 6. But there is no element at index 6. So there's the index out of range error. Instead, the final element will be the length of L minus 1. So that's another way. We saw a way to do this with negative indices in the previous lesson, but here's another way to extract the final element of the list. Use the index length of L minus 1. So there it is, the length function. Another extremely useful function, essential function, that we will use with list is the in function, in. The in function is a Boolean type function. That is, it returns a Boolean. So here's something that we could try. The number 1 in L. Hey, that's true because that's in there. 1.0 in L. Hey, it's in there as well. How about 2 in L? Well, if you look through the elements of the list, none of the elements are 2. Now, you might wonder about this a little bit because if you look at the list, you see 2 there, but you see it as an element of a sublist. Okay, so when you say 2 in L, what you mean is this: is 2 one of the objects in the sequence that is L? And the answer is no. It is there as one of the elements in a subsequence in L, but it's not one of the elements in the sequence that is L itself. Now, we could see that 2 is in that subsequence if we like. How could we do that? Well, let's extract the element at index. Let's use -1. Remember that that's the final element, right? And that's the sublist 2, 3, 5, 7. And is 2 in that? Well, yeah, 2 is absolutely in that. But again, the point is this, is that it's not in the list L, it's in a sublist of L. All right, so now let's actually write a little bit of code. What we'll need to do with lists very often, I think in almost every case, the functions that I have you write, is we iterate through them. That is, we go through the list element by element and we consider what is in that list. So I'm going to go over to the code editor and write just a little bit of code. So let's see if I can copy here. I would like to get that list. So copy and then paste. There we go. So that list is now in the code. And then we can iterate through that. You know how for loops work, right? It's the way they work with strings. It's the way they work here with lists. We have for loop variable in sequence name. Okay, and the way that this will work, of course, this is that the body of this for loop will iterate once for each item in the sequence. So it will iterate for the 1, for the 1.0, and so on. And the loop variable will be the value of the item at the element at that particular position. So the first value of item will be 1, and then the next time through the loop, the value of item will be 1.0, and so on. And I won't do anything fancy initially. I'll just simply print what that item is. And then let's run the code. Okay, so there it is. So we iterated once for each item in the list L. So we iterated 6 total times because the length of L is 6. And the first time through that iteration, item had a value of 1, and then it had a value of 1.0, and then a value of true, and so on. So that's the basics of it right there. That's how we iterate through a list. Now let's actually put this to use. Let's write a function because that's who we are in this class. We are function writers. So let's write a function that will count the number of odds in a list. And here's, I think, is a good way to do that. Of course, we'll have to iterate through the list. So we'll have a function that does that. But for each element of the list, we'll also have to determine whether that particular element is odd or not. So let's write a second function that doesn't iterate through the list, but instead a second function which takes a single number, single integer, presumably, returns true if that integer is odd, false if it is not. So we'll call this isOdd. This will take the number n, particularly the integer n, and it will return true if that is odd, false if it is not. Now, there's a complex way that one could do this. I'll show you a simpler way in just a moment. Probably the way that you would think to do this initially is something like this. Hopefully you do remember how to test whether a number is odd or not. It's all about the remainder when you divide by 2. And remember, of course, the percent, so-called percent operator. It's not really percent, it's the remainder operator. So that's the expression I just typed on line number 2, is the remainder when n is divided by 2. Well, if that is 1, then we could return true. It is odd because that's what odds do, right? When you divide by 2, you always get a remainder of 1. Otherwise, we could return false. So let's actually test this function to make sure that it works. So is odd, how about 3? Should return true. Is odd 4, should return false. Yeah, so the function seems to work. But let me actually go back and simplify this a bit. You should be able to do this by now. We could simply do this. Look at the expression n remainder 2 is 1. That itself is a Boolean expression. It will return either true or false, okay? It will return true when the remainder is 1 when you divide by 2, false otherwise. And so that's exactly what we want for the isOdd function. So this is a much simpler way to write the code. So isOdd, try it again with 3, which once again is true. We could try it with 4, which once again is false. So our function does seem to work. All right, so let's go back over now and write a second function. And this function will be, I'll just simply call it count because it could actually count many different things potentially. No, I'll go ahead and call it count odds because we'll write it so that it counts only odds, but you could easily modify it so it could count objects with a different property if you like. So it will count odds in a list that we send it. So I'll use the parameter capital L to represent that list. So for number in L, so we'll iterate through all the numbers. Ooh, and we'll also need another value as well, right? We'll need to have a count variable that we can increment every time we find an odd. So of course that means we have to initialize it. So we initialize count to 0. And then here's what we've got. So if is odd, sum, should be clear what that means, right? So we'll take that particular item from the list L. We'll ask whether that's odd. And if it is, we'll increment the value of count by 1. And then we back out so that we're at the same level of indentation as the for itself, which is the original level of indentation of the function, which means that this line number 9 will be executed once the for loop is complete. we will return the value of count. Okay, so let's run the code and let's count the odds in a list. Type. Okay, so there's the list that contains the initial positive integers 1, 2, 3, 4, 5. So let's make sure we know what the answer should be. It's not much use to test a function unless we know what the output of that function call should be. There are 3 odds in that list, so we should get a 3. And I lost my connection, so tell you what, let me go and run the code again. So we will count the odds in the list once again that contains integers 1, 2, 3, 4, 5. And it should be 3. There it is. So I have great confidence that our function actually works. Okay, so there's an example of the kind of work that you will do with functions. You will write a function that takes a list, will process through the list with a for loop and determine something or another about the list, like in this case, count the number of odds, and then return the result of whatever kind of process we went through. Okay. Now, there's something else that we'll have to do with lists as well. Sometimes, like we saw, we have to iterate through them. Sometimes we actually have to build lists. And the function that we wrote, count the odds, we didn't return a list, we just simply returned a number. But sometimes we actually have to build a list and then return that list. So let me go back over to the code editor and start over again. Here's what we'll do, okay? We're going to write a good little piece of code here in just a moment. Let's write a function that returns a list of primes less than or equal to a given value. Okay, so again, what we wish to do is to write a function that returns a list of primes that are all less than or equal to a certain value. Okay, so the way that this will have to happen is we'll have to start with an empty list, and as we find odds, we will have to add them to that list. Now, that means that we have to know how to grow a list, how to increase the number of items that are in a list, add items to the end of a list in particular. And there are 2 ways to do this, and actually we should hop over to the console initially so we can talk about these 2 ways to grow a list. The 2 ways are concatenation and the append function, okay? And we will have much more to say about the differences between these 2 in a later lesson, but for now we'll just look at examples of them, okay? So here's a list, 1 and 2 and 3, and we can concatenate to that another list, 4 and 5, okay? And there it is, 1, 2, 3, 4, 5. And if we happen to have names for those lists, like A is 1, 2, 3, and B is 4 and then 5, then we can concatenate by the names as well if we'd like. So there it is, A plus B. There it is, 1, 2, 3, 4, 5. Something to note about concatenation is that we have not changed, when we concatenate 2 lists, we have not changed either list. So if I look back again at A, it's still 1, 2, 3. If I look back at B, it's 4, 5. So if I actually wanted to capture the value that is generated, the list that's generated when I concatenate, I would have to assign it to a variable. Oops. Need to hit return, so I'll go again. So I could say that C is A plus B, and then that variable assignment did occur. And if I wanted to see the value of C, I could tap it into the console, and there we go. Okay, so that's typically what you have to do in the case of concatenation. If you concatenate, it will be on the right-hand side of a variable assignment statement, and on the left-hand side will be some variable name that will allow us to capture the concatenation that was returned. Okay, now there's another way to grow a list, and it's by use of the so-called append function. Really, I should call that the append method, given the way that we'll actually call this function. We've seen examples before where the way that we call a function is object dot function name. That's precisely what we do in this case. So we'll have a list name dot append, and then after the append in parentheses will be the object that we wish to append to the list. Okay, so there it is, C once again. We'll append to C. C is 1, 2, 3, 4, 5. So here's how we could append to C. Let's say that we wanted to add a 6 to it. So the syntax here will be C dot append 6. And that's really just a function call written in a different kind of way than we have usually seen up until this point. The name of the function is append. It is called on the object C with the additional argument 6, which just means that 6 will be appended to C. Okay, so I typed that in, and Python accepted that. It was perfectly happy with it. And then if we wish now to look at C, we find that it's the element 1, 2, 3, 4, 5, 6. So just a quick comment here, that's something that we'll certainly return to. When we use the append function, we actually changed the list. The word that's usually used here is mutate. What we did is we mutated the list. So the name C then refers to a list whose contents have changed. But like I said, we'll come back to that. So then we have two ways to actually add elements into a list. We can use concatenation or we can use the append function. Okay, so here's what we wish to do then. This is a really good piece of code that we'll write. We'll generate a list of primes, all less than a given value n. So it seems to me that a really good way to approach this task is to break it up into at least two functions, like we did in the case with count odds. We wish to have one function which takes a number n, returns true if it's prime, false if it's not, and then a second function that actually builds a list of primes, which means, of course, that it will have to call that function that determines whether a given number is prime or not. So here's the first function, is prime. So what we wish to do is to take a number n and determine whether that is prime or not. Okay? All right, so let's think about how it is that we do this. What does it mean for a number to be prime? Well, it means that it's not divisible by any numbers other than 1 and itself. Okay, so for instance, like, I don't know, 7. 7 is certainly prime, and why is 7 prime? Well, consider the numbers from 2 to 6. It is divisible by none of those, and since it's divisible by none of those, it is prime. Take another number like 12, which certainly is not prime. One way to know that it is not prime is to consider just, say, 2. A number greater than 1, less than itself, it is divisible by that 2, so it is not prime. So the natural way to approach this problem is to iterate through all numbers from 2 to 1 less than n and ask whether it's divisible by any of those. Okay, so let's begin to write some code. For, I'm going to use a long variable name here just to make sure that it's really clear. So what we look for are potential divisors. And what are the potential divisors that we need to consider? Well, we need to start at 2 and we need to go up to n minus 1. And of course, you know how the range function works. If we set the stop value to n, that means that we'll actually stop this iteration at the value n minus 1. Okay, so let's see. If the remainder, when n is divided by that potential divisor, is 0. Okay, that's what even divisibility is. That's what it means to be divisible by a number. That means the remainder is 0. So if the remainder is 0 and we divide by that potential divisor, we want to return false. And otherwise, if we can go all the way from 2 up to n minus 1 and never find a divisor, that should mean that the number is prime, and then we return true. Okay, so we've written some code, and of course we need to check it. So is prime, I'll try 7. Ooh, that's correct. 7 is prime. Let's try 12. Ooh, that's false. But we know as well that we better test edge cases, right? So 1 is, ooh, wow, that's actually not correct. We'll have to think about that in just a moment. I want to try 2 as well. Okay, so 2 is prime. So I think it does actually work once we're past 1. Now, the modern definition of prime number, on that modern definition, 1 is not a prime. The first prime is 2. And let's think about why our function got that wrong. Okay, so we would have had for potential divisor in range 2, comma 1. And let's actually see what that range is. Okay, so 2, comma 1. Ooh, that's the empty list, of course, right? So that means that our for loop never engaged. The body of the for loop never actually executed. That means that we immediately hop to line number 5 and return true. Well, how do we handle this? Here's a cheap way out. To simply test whether our number is 1. And if it is, we return false. And the function works for all other values, so this should be good. Perhaps you can come up with another more clever way to do this, but this ought to work. That is one way to handle edge cases, just test for them explicitly. So is prime 1 should now be false, is prime 2 should be true, 3 should be true, 4 should be false, and so now I think our function is correct. Oh, another note about this function, it actually does more work than is necessary. You don't actually have to test all the way from 2 up to n-1 for divisibility, and perhaps we'll talk about this later on, but anyway, the function does work. Okay, so second function. This is the function that will actually build and then return a list of primes, okay? So we'll call this prime list, and it will take a value n, and I tell you what, I'll give a comment here to, I'll type out a comment so we know exactly what this function does. So return the list of primes less than or equal to n. Okay, so how is this going to go? Well, we're going to build a list, okay? That means that we're going to take a list that we're going to add to it, but you can't add to a list unless the list exists and has a value. And of course, the right initial value is just simply the empty list. So there it is, the empty list, the list that contains no elements at all. And then for potential prime n, well, we want to consider all numbers in a particular range, and that will go from 1 to, let's think about the stop value here. Remember, the way the stop value works is we don't ever actually reach it, but we do wish to consider the value n, that's the potential prime as well, so we need to set the stop value to n+1. Okay, so what do we have now? If is prime, so we'll call the is prime function on that potential prime. So if that potential prime is indeed prime, well, what are we going to do? Well, we need to grow L. We need to now include that potential prime in L, and there are two ways to do this. We can do it with concatenation, or we could do it with the append function. I'll show you concatenation first. So it would be L is equal to L plus, and I'll make a mistake. This is a very common kind of mistake. And I actually will show you then what happens. It's almost right. We'll have to come back and make a small change, but I thought I would make this mistake so you would see it. Okay, so we might think that we've built the list that we want, and we can simply return that list then. That is return L. Ooh, we have invalid syntax. So let's see, what did we do wrong? Line number, ooh, that's not 4, that's def, sorry. I'm sure you saw that initially, so now it's been fixed. Let's run the code again. So let us build and then return all primes that are less than or equal to 12. Ooh, we got the error. Read your errors. I often have people that come to me with an error, but they've never read the error. They've never looked at the line numbers on which the error occurs. So let us read the error. It says type error can only concatenate list, not int, to list. And that occurred on line number 14. So let's look at line number 14. Okay, so what happened on line number 14? That was L equals L plus potential prime. That is list equals list plus integer. You cannot concatenate an integer to a list. If you concatenate to a list, what you concatenated must be a list. So what we have to do in this case is we have to make a sometimes called a singleton list, that is a list that contains only one element, that contains that potential prime. Okay, so let's try again. So prime list. So hopefully we'll get all primes less than or equal to 12. And hey, we've got it. Okay, we've got it. So that's how it can be done with concatenation. Okay, and let's make sure that we do understand why it is that line number 14 looks the way that it does. Okay, so on the right-hand side of that variable assignment statement, we created a new list that was the result of the concatenation, and then we had to store that list value away somewhere, and the natural candidate is L. That becomes the new value of L. Okay, so let's do this in another way. And how actually you do this for us doesn't, in most contexts, make any difference at all. So you can pick and choose. You can choose which one you wish to use. I tend to choose append. So let us see append. Okay. So if we use the append function, it will be L.append potential prime. Okay. So that is a call to the append function on L and this second argument, potential prime. And what it does is it mutates the list L and puts potential prime onto the end. And notice that in this case, the potential prime doesn't have to be converted into a list. We could append any kind of object we wish to a list. That's just simply how the append function works. So let's try it again. So prime list 12. And once again, we get all the primes less than or equal to 12. So there are two examples of the kinds of work that we have to do with lists. One example, we wrote a function that actually took a list and then worked its way through the list and produced some output. What we saw was a function that iterated through a list, processed through a list, and returned the number of primes that were, odds that were in that list. And then here now, in the code editor, we see a second kind of function that works with lists. And what it does is it builds a list inside the function and returns that list. That is, in this case, a list of primes. Now, next time we're going to have to come and talk about a certain feature of lists that I've alluded to. That is that lists are mutable. And we'll have to look at some functions that allow us to mutate lists. And then later on, we'll also have to talk about the danger that arises when you have mutable data objects like lists. But that's it for today.